According to the law of inertia, we need a force to either move a mass or to change the movement of a mass. But what happens if we change the size of the mass? How does a big object respond to force differently to a small object? Well, that is where the law of acceleration comes in, and it describes the way that masses of different size respond to different forces. So I'm sorry to throw an equation at you here, but I'm going to throw an equation at you here. So this equation is a really good and simple way of describing the law of acceleration, and I hope you will agree it is a good way of going about it. But don't get scared off just because there's a bit of math and there's a bit of algebra going on here in this video. So the law of acceleration, we start off, the equation for the law of acceleration, we start off with this. We start off with a force. Okay, so we have a force here. Now the force equals, which means we can calculate or estimate the size of that force. So the force equals the size of the mass. So the size of the mass that the force is being applied to. And if we multiply the size of that mass by the acceleration that the mass demonstrates, so the mass acceleration, then we can estimate how big the force was. So the size of the force is in effect related to the size of the mass and then also the acceleration that the mass demonstrates. So what does acceleration mean? Well, you've probably heard of the accelerator in your car, which helps your car speed up, and it's the same concept. So if we look at our ball here from the law of inertia lecture, so we've got ball 1 here, and we apply a force to make the ball roll along the table, just like I described in the law of inertia video, then that ball is going to go from rest, so it's going to go from 0 speed, and it's going to move forward. After the force is applied to it, it's going to have some speed or velocity. And so it's gone from 0 speed or velocity up to whatever speed or velocity it has. And so that means it has accelerated, it's sped up. So as a result of the force, the mass has accelerated. And hence we have this equation here, which you'll often see referred to as F equals ma. And really, it is exactly the same thing as this equation here. Force equals mass times acceleration. So let's tweak this equation. Let's look at how it can affect the way that these different masses can move around in space. So here we have ball 2. And ball 2, let's assume it is twice the mass as compared to ball 1 here. So it's double the size. Now if we apply the same force, same force to ball 2, because it is twice the mass, the result is it's going to have half the acceleration. So hopefully that kind of makes sense. Because the ball is bigger, we've got the same force, it's going to accelerate half the amount. So it's going to end up moving slower. It's not going to speed up as much. Whereas if we apply a bigger force to the ball, we might get it up to the same speed as the smaller ball, but with the same force, with twice the mass, it's going to move half the speed. So it's got half the acceleration. And that's really the crux of the law of acceleration, is that for any given force, a bigger object is going to accelerate less than a smaller object. So that's sort of the abstract explanation that we've got here. But let's then look at how it applies to the body. So you can see I've got this picture here from Wikipedia showing the muscular system. Hopefully it's not that far a leap for you to realize that and to understand that a big male dancer is going to need more force applied to his body to produce the same movement as a smaller female dancer will. So the same law of acceleration applies here. So it applies to whole body movements, but it also applies to the different parts of our body and the forces we need to move those different body parts. And we look at this in more detail in the balance course that hopefully you will subscribe to. But let's have a look here at our anatomy model here, and let's consider his leg compared to his arm here. So hopefully you can appreciate the leg here. The leg here is a big mass, and the arm here is smaller. Smaller. So just like with our whole body and with our balls here, bigger masses need bigger forces to produce the same movement. Or if we apply the same force to the arm and the leg, because the arm is smaller, it's going to have less acceleration. It's going to have more acceleration than if we apply the same force to the big mass, to the leg. So bigger things need more force to move than smaller things. This is really the crux of the law of acceleration here. So in the next lecture, we're going to look at more application. We're going to look at Newton's third law, which deals with action and reaction, and really gets to the basis of how the body interacts with the environment and how actual movement occurs through space.